So before we start, you need to write down all 5 or 6 laws of indices that we've come across, and then I will write them down in a moment. Keep them on your whiteboards because we'll use them as reference for today. Section 3.5, please. Section 3.5. So as soon as you see the power, the unknown is the power, then you're going to apply logarithms. Now, because in C2 you've got a calculator, it's possible to work x out as a non-integer value, so it can take on any value. And we use this quite a lot for geometric progression, so that's one of the chapters that we're going to use later on. As soon as you see the unknown is in the power, what we can do is we can take the logs of both sides. Now, it doesn't matter which base it is, and remember, if we have log, it's exactly the same as log to the base 10, and that's what you use on your calculator. Okay, as soon as you see log, it's log to the base 10, and we use it on a calculator. So I can take logs of both sides. Because it's an equation, what I do to one side I can do to the other. Why would that help me to find out what x is? Look at your laws of logarithms and which one can I use? That's the question. If we look at log to the base a x to the n, that allows us to simplify and put the n at the beginning. So if I apply that to this one on the left hand side, I'm going to get x by itself, and I'm going to get an easy equation that I can solve, yeah? So applying that law, we get x log 3 is equal to log 20. So I can find out x by just taking log 20 divided by log 3. Can you work that out on your calculator? Remember, write the full display. And it's asked for 3 significant figures, so full display and then round it. So full display is 2.726833.028 and so on. And if we want our answer to 3 significant figures, it's going to be 2.73 and 3 significant figures. I advise you to pop that in a bracket afterwards, so when you're coming back to check your answers, you know what accuracy. It saves you reading the whole question again. Right, moving on then. Let's move on to this one here. This is similar to what you did in C1, except the numbers don't go quite nicely into powers of, in this case it would be 3. We cannot express 7 in powers of 3, so it makes it a little bit trickier. So the same thing again, we can use the power laws we did before. We will take logs of both sides, so log 7 x plus 1 and log 3x plus 2. Apply that power law. So the x plus 1 comes in front of your log. I'd be tempted to put it in brackets just to make it clear, and then x plus 2 goes in front of log 3. And remember, log 7 and log 3 are just numbers, that's all they are. Right, we want to try and isolate x, so this is quite a complicated one to solve because we've got x's on both sides. So what we're going to have to do is multiply each side out. So we're going to have x log 7 plus a log 7 and on the right hand side we're going to have x log 3 plus 2 log 3. Take the x's to the left hand side and then take the log 7 to the other side. Just check your signs, make sure you've got that right. I'll take out a common factor of x and that'll isolate it. And then x by itself is going to be 2 log 3 minus log 7 divided by log 7 minus log 3. It's asking for the answer to be 4 decimal places. Can you do the full display on your calculator and then round it? So full calculator display is 0.2966069431. We want the answer to 4 decimal places, so it's 2966, 4 decimal places. Before we go on to the next example, which is example 10, where we've got a quadratic in disguise, like my wee cartoon. Say what you see, catchphrase. Before we do that, I'd like to, going back in your booklet to example 10, please. What we've got here is a quadratic in disguise. That's what's happened here. Now, how is it a quadratic in disguise? Because if we look at the 5 to the 2x and the 5 to the x, there's a relationship between two of those that can convert this into a quadratic, and this is how it works. We could write 5 to the 2x using our laws of indices, 5 to the x all squared. If that's the case, we get 5 to the x all squared plus 7 to the 5x minus 30 equals 0. And if I say to you, let y equal 5 to the x, then this turns into a quadratic, y squared plus 7y minus 30 equals 0. Can you see why I've said that that's a quadratic in disguise? So you wouldn't think about it in terms of the 5 to the x, but it takes us now on to solve a quadratic, and hence we can find x. These are the type that happen in the exam most often, because when you look at it, first of all, you think to yourself, I don't recognise any of that. I know the unknown is in the power, and I know I've got to use logarithms, but how do I do that? Because there's too many terms there. The ones that we have just looked at have got one term on the left hand side and one on the right hand side. And that's fine taking logs of both sides, but when we get something complicated like this, we've got to apply the quadratic method. We should be able to factorise this. So let's pop it into 2 brackets. We've got no choice but y and y, and we want factors of 30, which will give us a difference of 7, because we've got a minus sign. Because we've got a minus sign here, we need a plus and a minus in the brackets. So that should give us plus 10 and minus 3. So from that, we get y equals minus 10, or we get y equals 3. Now we can't just stop there. It's like our simultaneous equations. We've found out what y is, but then y is also 5 to the x. So 5 to the x is equal to minus 10, and 5 to the x is also equal to 3. What can you tell me about this first one here? Think about our exponential graph. Remember from last lesson, the exponential graph looks something like that, doesn't it? And it goes through the point 0, 1. So what can you tell me about this equation here? Just looking at the graph, there is absolutely no value of x that will make minus 10, because minus 10 is down here somewhere, and that's never going to happen. So what we say is there's no solutions for this one. But if we look at the second solution, we can do that because we can just take logs of both sides again and work it out from there. We want an answer to 2 decimal places. So x is equal to log 3 over log 5. Write the full display. And the full display is 0.6826061 and so on. And we want an answer to 2 decimal places, so it's going to be 0.68. I'd like us to look at question 2 and part D. The question asks for a solution for x, and this time that's the equation that we've got. This one's a little bit trickier simply because of the 3 to the x plus 1. We've got to incorporate our laws of indices. So I've got to do one more step with this one. So it's going to be 3 to the x squared, and then thinking about your laws of indices, that's 3 to the x multiplied by 3 to the 1. And you can see there the same base number of 3, and our laws of indices would just say add those together. So I can do exactly the same thing. So I have 3 to the x all squared plus 3 times 3 to the x minus 10 equals 0. We've got a quadratic in disguise again. We say let y equal 3 to the x, and we go about it in exactly the same way. So y squared plus 3y minus 10 equals 0. Factorise it. I think it's going to have to be 5 and 2 plus a 5 minus a 2. So y is equal to 2 and y is equal to minus 5. Y was 3 to the x. So we can see again from the second one, there's no solutions to that one because we've got a negative value, so no solutions to that one. And then we apply logs to both sides. And we get x is equal to log 2 divided by log 3. We're asked for the answer to 3 significant figures, so we'll do our calculator on that. And the full calculator display is, which is approximately equal to 0.631, and that's to 3 significant figures. Right, what I'd like you to try, so what I'd like you to try now is question 2. Oh, James, I don't know what's going on there. This is going to be a real mess, I think. I want you to do question 2 and those ones there. We've already done part D, I don't know. Right, we're going to move on to the previous example. So, exercise 3E, question 2, A, C, E and G. I'll give you 5 minutes for that one. So, checking your answers to question 2, we want them all to 3 significant figures. And part G, it's the quadratic that's quite tricky. I think we got 3y squared minus 26y plus 9 equals 0, and then you had to factorise that. We use 3y and y and 9 and 1. Was it a plus and a minus? Was it the others? Minus 9 and plus that one. Was that the right way round, or are they both minus? That's right. So that should be a plus there and a minus there. No, I think is that a minus as well? So that one's a minus and that one's a plus. So we get y equal to minus a third, so that's got no values, and y equals 9. We said y was 3 to the x, so there's where you get x equals 2. Won't get the change of base done today, but we'll finish that off on Friday, and we'll also do stats on Friday.